Hello class, this is Mrs. Klusek. In this video I'm going to try to explain the difference between the sine and the cosine wave. When I explained the sine wave, we started by graphing the ordered pairs that correspond to the y values. So at 0, what I had was 0, 0, and that was the first point that I wanted to graph. But for the cosine, I'm going to start at 0, 1. To show you a better model of this, I'm going to switch to a graphing calculator. On this graphing calculator, you can see that the x-axis has 4 tick marks, 1, 2, 3, 4. And on the x-axis, this tick mark represents pi over 2. This tick mark represents pi. This is 3 pi over 2, and this is 2 pi. I can also look at this in my window. I've adjusted my window to match these dimensions. 2 pi is actually in decimal form here. Another important part is when I'm using my graphing calculator, I need to switch to radian mode, because remember those increments on the x-axis of pi over 2, pi, 3 pi over 2, and 2 pi are in what we call radians. Okay, now in the y equals menu, I've already stored some functions. I want to compare the sine wave, so I'm going to activate this one. And I'm going to activate by clicking on the equal sign these two waves. This first one here in blue is the sine wave. This next one here in pink is the cosine wave. And sine wave starts at 0, 0, then goes up, and then hits the x-axis, then down to -1, then back up and hits the x-axis. The cosine wave has a similar pattern to it, but it starts at 0, 1. That's key to understanding the difference between these two graphs. All right, on the first video, I showed you different sine waves comparisons. Now that I'm using a graphing calculator, let's just compare these 3 sine waves. I have the basic sine wave, which is my parent function, 2 sine of x, which is going to change the amplitude, and then sine of 2x, which is actually going to change the frequency instead, or the period, how long it takes to complete a cycle. All right, so here's my basic parent function of the sine wave. I now have any cosine wave, so you can see they all hit at 0, 0. This next one that's in the color red is the amplitude change, and then this one is the period change. And as you can see, it has to go at a faster space to get to the final endpoint. So what it does is it actually doubles the amount of times that it makes the cycle. All right, now let's take a look at the cosine wave variations. I'm going to deactivate the sine waves. And my cosine wave comparison is just going to be the basic parent function, a one with a -1 in front, and then this one is going to be the frequency change. Here comes my parent function of the cosine wave. And here comes one with a negative in front, making it go in the opposite direction. And here comes the one with the frequency change. Now you'll notice that this one actually spreads it out. It stretches it instead of going faster. The 2x made it double. This one made it cut in half. Thank you for watching. I hope this makes sense. I'll draw some examples for you to follow as well.